A transverse wave is a wave that vibrates perpendicular to its axis. An example of this would be a wave on the surface of the ocean. A longitudinal vibration or wave is when the vibration is parallel to the axis. An example would be a spring bouncing up and down. Finally, we have torsional waves. This is when the vibration is twisting around the axis. One example is a twisted slinky unraveling itself. The first property or factor we have is cycles. This is the part that continues to repeat itself over and over again. Next up, we have frequency. This is a measurement of how many cycles per second. This shows how fast the wave is oscillating or vibrating up and down. Now we have period, which is how long it takes for one cycle to be completed. This brings us to hertz. Hertz is a measurement equal to 1 cycle per second. So a frequency of 5 hertz means there's 5 cycles happening every second. Amplitude is the distance from the axis to either a crest or a through. Then we have the wavelength, which is the distance covered by one cycle and is a measurement from one peak to another.
When a wave meets a new medium, the speed changes abruptly. Since the wavelength is directly proportional to speed, when a wave goes from slow medium to a faster medium, the wavelength is shorter since the speed is faster. At the same time, when the wavelength decreases, the frequency increases. There are two types of reflections. Fixed end reflections are when one end of the wave is attached to a more dense, therefore slower, medium, and the pulse of the wave inverts in the opposite direction. Free end reflections have no inversion, and instead the pulse just returns in the opposite direction. These happen when one end of the wave is attached to a less dense medium. Partial reflections happen when a wave travels into a new medium. Not all of the energy is transmitted to the new medium, therefore, by the law of conservation of energy, the energy then returns the other way. The reflection is inverted while moving from a fast to slow medium, but not inverted from a slow to fast medium. Because of this change, the wavelength and speed both change.
Waves can also interfere with one another. This is known as constructive and destructive waves. Constructive waves are when two positive waves or two negative waves come together, overlap, and form a larger amplitude. Destructive waves are when a positive and a negative wave collide, reducing one or the other's amplitude, creating a smaller wave.
Mechanical resonance is the transfer of energy from one object to another object that has the same natural frequency. It must be considered while building bridges and buildings. Every object has a natural frequency. For example, when pushing a swing, it will swing at its natural frequency. If you were to swing your legs at the same frequency, the swing will gradually increase in amplitude, therefore making it swing higher. If something is outputting the same frequency as an object's natural frequency, it will vibrate. This is called sympathetic resonance.